Hi everybody, we're back with the sine function, and what we're going to do here is quickly draw the sine function. So here's the graph of y equals sine x. Obviously this one is many to one, and the inverse of this will not be a function, same as for cosine. We'll now draw the inverse of the sine function. The inverse of the sine function is going to be x equals sine of y, and I will draw that now. So here's what x equals sine y looks like. It is a one-to-many relation. It's not a function. It goes up and down forever. So what we'll need to do here is decide which piece of this graph we want to adopt and take over as our inverse sine function. And there's, I think, a fairly obvious choice when you think about it. You clearly want to keep the part that's just in the positive zone here. You want to keep that for sure. So you're going to have to keep a chunk that covers x running from -1 to 0. So what chunk would you like to keep?
Negative.
So yeah, we would choose a piece that's connected so that it's smooth and continuous, and we would just continue this down here, right? Mm-hmm. So that's the piece that we're going to keep as our inverse function. So it feels as though we're inventing this for ourselves, right? We're really just reinventing something that somebody else has figured out a long time ago. And everyone in the mathematical community around the world chooses the same piece. So this is our graph of y equals inverse sine of x, also known as y equals arc sine of x, which you will also see written as a sine of x if you're working in Excel or with some sort of program like GeoGebra. And on your calculator. This is the graph you get if you have a graphing calculator and type that in. These are the values you get when you use the calculator buttons for inverse sine. Now let's look at the tangent function. Okay, so there's our tangent graph, and we can see that it obviously fails the horizontal line test. It passes the vertical but not the horizontal. So again, this is a many-to-one function, and its inverse will not be a function. Be careful when you graph the inverse. Make sure that you actually think about the graph carefully. It's a reflection across the diagonal line, y equals x. It's not a rotation. So where people make mistakes here is they get the graph going the wrong way. Here's what the first piece of the inverse tangent function looks like. Notice that it goes on forever to the right and left. I'll now draw the rest of the curve in. So here we have the entire graph of x equals tan y, or at least I have what I can show on this screen. Obviously this goes up and down forever and repeats. It fails the vertical line test, so it's not a function. But we'd like to have a function, because our calculator has one, and we want to have the same thing as our calculator has. So which piece would you keep? I think it's obvious here. You would keep the one in the middle. Keep in mind it goes on forever, left and right. So this is one that approaches horizontal asymptotes. Notice that it is an increasing function going from the bottom left up to the top right. So let's draw it. Here we have the graph of the inverse tan function. Let's just write down what the possible equations are. We can write it as y equals inverse tan x like this, or we can write it as arc tan of x, or we can write it as y equals a tan x. Those are all acceptable notations. So there's our three inverse trig functions.